Hello and welcome to another episode of Research Talk. Today we have with us Dr. Kingshuk Bag from Purva Bardhaman, West Bengal. He completed his BSc from Ramakrishna Mission Vidya Mandir College, Calcutta University in 2016. And then he pursued his integrated PhD at the Indian Institute of Science, Bangalore. He is currently working as a research associate at Indian Institute of Science, Bangalore. His research interests include carbohydrate chemistry, supramolecular chemistry, and their applications at the biological interface. In today's session, he will present his work titled as Synthesis and Self-Assembly Studies of Carbohydrate Bolaamphiphiles. So, Dr. Kingshuk, welcome to the talk and the screen is yours.
Thank you, Mas, for your kind introduction. And thank you, Turning Point, for giving me the platform to talk about my research work. And I will talk here synthesis and self-assembly studies of carbohydrate Bolaamphiphiles. Before going to my work, I will talk about self-assembly and what are the factors involved in the self-assembly process. In self-assembly is the creation of desired nanostructure and materials properties through the organization of designed molecular building blocks exhibiting the proper inter and intermolecular interaction along with the parallel control of the solution assembly pathways to yield the desired structural outcome. In simple words, self-assembly terms refer to the process by which smaller components come together to form a larger structural unit. In order to effectively guide the molecules into supramolecular structure, it is crucial to design the building blocks with an understanding of non-covalent interaction, such as the hydrogen bonding, hyperstatic interaction, electrostatic interaction, and van der Waals interaction. And based on the polar and apolar segments and linker between these two, it will molecules are divided into four categories, which are the amphiphilic moiety, Bolaamphiphilic moiety, Gemini amphiphilic moiety, and double and triple gel amphiphilic moiety. And in amphiphilic moiety, the one part is the polar segment and another part is the non-polar segment. In Bolaamphiphiles moiety, the two polar part are linked with a non-polar segment. In this non-polar segment, which is anything like a lipid chain as well as the aromatic building blocks, and here I will discuss about more about Bolaamphiphilic moiety. At first, we start our synthesis. Synthesis of Bolaamphiphilic moiety. Objective is this or exploit the chiral amphiphilic nature of the terphenyl glycosides for use as a building blocks in the chiral self-assembly process. Why carbohydrate? It has some advantage like increased aqueous solubility, hydrogen bonding interaction, rich in chiral carbons, and decrease the cytotoxicity. Why terphenyl moiety? It has some advantage like pi-pi stacking interaction, optoelectronic properties, and multiple site for functionalization. We started our synthesis starting from the 4-formyl boronic acid and 1,4-diiodobenzene undergo the Suzuki reaction using the palladium-based dendrimer catalyst to give the terphenyl dialdehyde moiety, which undergo the reductive amination by using ethanol amine attached mannose and ethanol amine attached rhamnose will give you the mannose attached Bolaamphiphilic moiety and rhamnose attached Bolaamphiphilic moiety. Important characteristics of this molecule is the supramolecular chirality, where it will, in the circular dichromism give you the two type of spectra, whereas the mannose attached Bolaamphiphilic moiety give you the left-handed helical structure, whereas the rhamnose attached Bolaamphiphilic moiety give you the right-handed helical structure. In this molecule, these terphenyl blocks give you the axial chirality, and whereas the sugar moiety give you the point chirality. This CD chirality is real by checking the linear dichroism spectra. Linear dichroism is nothing but the difference in the absorption of the light polarized parallel and perpendicular to the molecular axis. This linear dichroism give you the orientation of the molecule. And further, this right-handed and left-handed helicity confirmed by the AFM images. Manoj Bolaamphiphiles moiety give you the left-handed helical structure, whereas the Ramnoj Bolaamphiphiles moiety give you the right-handed helical structure. While further, we studied the self-assembly behavior, chiral self-assembly behavior of this molecule by CD spectra it at different temperature. And this different temperature dependent CD spectra give you the hysteresis. Hysteresis is nothing but the CD signal, which is CD signal does not completely return to its original value when the condition are reversed, indicating the molecule did not fully revert to its original conformation. And at this 40-degree temperature, the transition happened, and this transition of the helical structure is completely lost at 40-degree temperature. When we replace this terphenyl moiety using the biphenyl-Cored, the synthesis of this phenyl-Cored Bolaamphiphiles moiety, which is starting from the terephthaldehyde undergo the reactive amination, give you the carbohydrate Bolaamphiphiles moiety. First, we study the concentration dependent CD spectra, where it will give you no CD peak, which tells about the no chiral self-assembly in the solution phase. Further, it confirmed by microscopic images. AFM images give you the fiber-like structure, and ACM also shows no supramolecular chirality. So it suggests the supramolecular structure in terphenyl Bolaamphiphiles required terphenyl as a core moiety. Further, we replace this phenyl moiety using Biphenyl-Cored. For the exploit of the axial chirality of the amphiphilic nature of the biphenyl glycoside for use as a building blocks in the chiral self-assembly process. Depends on this biphenyl moiety, it will give you the supramolecular chirality, which in the CD spectra, this Manoj attached Bolaamphiphiles moiety give you the left-handed helical structure, whereas the Ramnod attached Bolaamphiphiles moiety give you the right-handed structure. These two spectra, was terphenyl and biphenyl, give you the similar spectra, but the intensity is less for this biphenyl moiety, and also the blue shifted CDF signal appeared. And also this Manoj and Ramnoj attached Bolaamphiphiles moiety, the supramolecular chirality further confirmed by AFM images and ACM images, where the Manoj attached Bolaamphiphiles moiety give you the left-handed helical structure, whereas Ramnoj attached Bolaamphiphiles moiety give you the right-handed helical structure. Then we studied the supramolecular chirality depends on the dependent pH behavior. This biphenyl-based Bolaamphiphiles moiety in different pH show different peak in the CD spectra, whereas at acidic pH the no CD signal appeared, whereas at basic pH it will give you the more prominent CD peaks, which tells us about at acidic pH that any is got protonated, and it will not show any supramolecular chiral self-assembly. And further, we confirm this study by using AFM and ACM TEM images. This AFM images showed the chiral tube-like structure, where as at basic solution it will give the fractal growth, and it fractal dimension around 1.9. And also at acidic pH, this fiber-like structure clipped into small particles. We study the mechanistic investigation of this self-assembly process. To investigate the chiral self-assembly process at its initial growth process, we took 4 molecules, and it will study the self-assembly process and study the microstructure in the initial growth process. This terphenyl-based Bolaamphiphiles showed four type of structure: for T1, T2, T3, and T4. T1 and T2 are the parallel and antiparallel orientation of the molecule, and whereas T3 and T4 are the slip structure. T1, T2 parallel. T1 is the parallel orientation where the two molecules are oriented 0 degree, whereas T2 the two molecules are 180 degree, 180 angular orientation 180 degree, whereas T3 and T4 are the slip structure. These T1, T2, T3, T4 basins, T1 and T2, that transition between the T1 and T2 is relatively high barrier, whereas the T1, T3, and T2, T4 observed more frequently due to its relative low barrier. Then we studied the biphenyl base Bolaamphiphiles moiety. Then it is also showed the four types of minima, where the barrier between these B1, B2, B3, and B4 almost less than kBt. So it is very less. So its transition is very fast, and it will give the intensity lower CD intensity. Then we study the pH dependent molecular dynamics simulation, and it will show that in protonation, the distance between the two molecules is more than the neutral pH, whereas at neutral pH, the distance between the two molecules is 1 nanometer, whereas at protonated state, it will give the around 2.5 nanometer. And the two minima give you the U1 and U2 give you the parallel and anti-parallel orientation of this two moiety. Then we further study the carbohydrate specificity using turbidity assay, whereas we chosen the three molecule. All are mannose attached. Mannose phenyl mannose, and mannose biphenyl mannose, and mannose terphenyl mannose unit. In all of the molecules have the two mannose unit. But when we study the carbohydrate specificity towards the conelactin, Cone is the specific for the mannose moiety. When we studied the turbidity assay, whereas the mannose terphenyl mannose unit is more increased the optical density than the mannose phenyl mannose unit, which tells about the both mannose are accept the Cone moiety, which give you the more increase in the optical density. And for the single mannose phenyl mannose unit, only one cone is approaching towards the mannose, so it will give less less increase in the optical density. Further, we added the alpha methyl D mannopyrrone site for the inhibition, competitive inhibition, where after addition of this alpha D methyl mannopyrrone site, that our mannose oligophenyl mannose unit you release, and it will decrease in the optical density. Then we studied the cell viability using MCF7 cell line, which is specific towards the mannose unit, but for rhamnose it will IC50 value are almost 89.6 micromolar. So it tells us about the L-rhamnose differs in the configuration from the carbohydrate building blocks of the mammalian glycan, except for the L-fucose, and we presume that the lack of appropriate configuration of the non-native nature of these ligands to its higher toxicity. In conclusion, that supramolecular chirality switches between D to L configuration of the carbohydrate moiety, and the biphenyl-Cored moiety is the lowest supramolecular synthon for the chiral self-assembly structure formation, and the supramolecular chirality depends on the pH, and also the molecular dynamics simulation demonstrated the microstructure of the self-assemblies in the initial growth process. Thank you for your kind attention.
Nice work and nice presentation, Dr. Kingshuk.
If you enjoyed this session, don't forget to like, share and subscribe. We'll meet you in the next episode, next session. Thanks for watching.